Hi there, welcome back to Box of Shorts. In this video, we're going to be looking at oxidation and reduction. Before we get started, a reminder that if you are watching this video from home, turn your phone off, close all your tabs, get some pen and paper ready so that you can do some work. And just by way of reminder, before we get started on this particular one, if you have not done the video on half equations, sorry about that. If you have not yet done the video on half equations, make sure you view that one first, because this video will not make any sense unless your half equations are good. So with your pen and paper ready, get started on these questions for me. Please pause the video and get started. Okay, you should by now have finished those questions, and we're going to start marking them. And again, a reminder that if you did not get those, did not understand them at all, make sure you've done the half equations video first. So we have a look at these ones. We need to balance the equations below. When I look at this one, I can see that I've got, just going to thin this pen a little bit, that I've got 2 plus on this side and 1 minus on that side. Now, overall, that's going to give me a charge of +1 because 2 take away 1. But on this side, I don't have any charge at all. So in order to make that balance, I'm going to put a 2 over there. I'm going to follow the same process for the next question. I can see I've got 3 positives over here, but only 1 negative. So I'm going to put a 3 over there. And that's my equation then balanced. For the next one, the first thing I can see is that I've got 2 atoms of oxygen there. So I also need 2 atoms of oxygen here. If I've got 2 ions of oxide, so 2 oxide ions. Now, if I've got 2 oxide ions and each one is 2 minus, then my total negative charge is 4 minuses, because I've effectively got an O2 minus and another O2 minus, which means 4 minus in total. So I'm going to pop a 4 over there. And that then is my equation balance. So just to clean that up and make it very clear what I've done, there is your final answer. For the next one, I've got magnesium ions from magnesium atoms. So I'm going to start with my magnesium atoms. I'm going to turn them into magnesium ions. I know that my charge on a magnesium ion is 2 plus because it's in group 2. And so I'm going to put 2 E minuses over there. What has to happen for magnesium to turn into those ions is for it to lose 2 electrons. And that's where that 2 plus comes from. Chlorine from chloride ions. So I'm going to start with my chloride ions. And again, I know they have a -1 charge because they're in group 7. And then my molecule of chlorine is going to look like that. So like with the oxygen example before, the first thing I need to look at is this number 2 over there, because I've got 2 atoms of chlorine on the right. I'm going to have to make sure I put 2 over there so that I've got 2 chloride ions. Now, when I look at the electrons, I can see that I've got -2 charge over there, and I've still got a 0 charge over here. So I'm going to add 2 electrons to bring that to -2 as well, and then my equation is nice and happy. This one's a bit harder. I start with Ti4 plus ions, and I turn that into Ti2 plus ions, and my charge has gone down. Okay, so it's gone from an overall of +4 to an overall of +2. Now, in order to make those the same, I could try and get that to be +4, but electrons won't bring a number up, they'll bring that number down. So if I put electrons on that side, that won't help. So I'm going to put my electrons on this side. If I put 1 there, that'll turn to +3. If I put 2 there, that'll turn to +2, which means my equation is now balanced and happy. What we're going to be looking at today is the addition of some new terms. And we're going to start with fairly simple equation that looks like this. I'm going to have Na plus, and it's going to pick up an E minus and turn to Na. Now, obviously, the same can happen in reverse. I could start with Na and turn that into Na plus and an E minus. Either way, it could work. I could start with the sodium ions and get sodium atoms, or I can start with the sodium atoms and get sodium ions. Now, chemists have a word to describe these two different types of reaction. In this type of reaction here, we would say that the Na plus gains electrons. Whereas in this one, we would say that Na loses electrons. And chemists have a word to describe that process. In this first one, we would say Na plus has been, and this is the new word for you, reduced. And I guess a good way to think about that is that the charge has been reduced. It's gone from positive down to 0. So the charge has gone down. Now, annoyingly, the term that we use for this process is that Na has been oxidized. Now, that's very similar to a term you've used earlier in the course when you're talking about the addition of oxygen. But in principle, you've got two, I guess, ways of defining it. And the way we're defining the word oxidize or oxidation today is that we're just losing electrons. So if that Na turns to Na plus, it's losing electrons. Now, a good way to remember that is the classic oil rig, where we say oxidation is loss and reduction is gain. And that's our good way to remember whether we're losing or gaining electrons. It's also really important to note that I've said Na plus and Na, because we always talk about the thing that we're starting with. In this case, it's the Na plus, and here it's the Na. Don't confuse yourself. If you don't write, Na has gained electrons if it's Na plus gaining electrons, and don't say that Na plus is losing electrons if it's Na that's losing electrons. Often students get confused. You just have to make really, really clear that that you're talking about the thing on the left, that you're talking about your reactant. Let's do an example. So get a pen and paper ready. I'm going to put 2 on the board, and I want you to write, I guess, similar sentences to what I've written. So this is the kind of thing that you are going to write next to mine. So try this one first. See if you can write sentences like mine for those. Pause your video and do that now. So I'm hoping that what you wrote here is that Mg2 plus has gained electrons, has been reduced. And here you can write Mg has lost electrons, it's been oxidized. And we're going to clean that up even more. And really the best way to write that is Mg2 plus has been reduced. And here Mg has been oxidized. This is absolutely 100% the best way to write it, the cleanest, the clearest summary that we can possibly imagine. Try 2 more for me. And these are exactly the sentence we're going to write. Try this one first. Let's go for try that one and try the one that we looked at before. Try those 2. So you should have done those by now. And what I'm looking for on this one is Al has been oxidized. And that's enough to get my mark. For this one, I'm saying Ti4 plus has been reduced. In the first one, I'm losing electrons. In the second one, I'm gaining electrons. Things get slightly more complicated when we talk about nonmetals. So let's look at one example that we were dealing with before. Let's say I've got 2 Cl minus forming Cl2 adds 2E minus. If you had to write a sentence for me, what would you write? Pause your video and write it down now. So I'm hoping that what you wrote was that Cl minus has been oxidized. It's lost electrons. These electrons have come from the Cl minus. And because it's lost electrons, it has to be an oxidation process. Let's try this one now. Oh, sorry. Try that one for me. Pause the video and try that one. So I'm hoping here you wrote O2 has been reduced. It has gained electrons, it's picked up some electrons, so it's been reduced, and it's now O2 minus. If you got those 2 ready, if you got those 2 correct, you're ready to do some practice. So I'd like you to get started on these for me, please. I'll maximize my screen so you've got a bit more space. There we go. Start on those for me. Pause the video and start those. Okay, you should have finished those now, and you shouldn't be listening to me unless you've done them. Let's have a look at some answers. So we've got equations below. I need to write half equation and then identify what's been oxidized or reduced. If you've forgotten to do that, then pause the video and make sure you do that now. And just go back. So in this one, I'm going to do Cl2, and it's forming 2Cl minus, and I'm losing my 2 electrons over here. And I would say Cl2 has been reduced. It's gained electrons, so it's been reduced. This is one that we did just before. O2 is turning into 2O2 minus. It's gaining electrons there. So in this case, O2 has been reduced. When I look at this one, I've got N2 turning into 2N3 minus. I'm going to have 6 E minuses over there. N2 has been, again, reduced. In this case, I've got Ca turning into Ca2 plus. So I'm going to have my 2E minuses over there. So Ca has lost electrons, so it's been oxidized. Br2 turns into 2 Br minus. Br2 has been reduced. Ozone is O3, turn into 3O2 minuses. We're going to have, again, 6 E minuses over there. And I would say O3 has been reduced. We're a bit top heavy on the reduction at the moment. It's not a problem. Fluoride ions, I've got 2F minus turning into F2. My 2 E minuses are going to have to be there. So I would say that F minus, that's crucial. You can't write F, you can't write F2, you can't write fluorine. You could write fluoride ions if you wanted. I just prefer to write the symbol. Has been, in this case, oxidized. It's lost electrons. And finally, for the boron ions, we've got B3 plus turning into B. It's going to be gaining electrons there. So we'd say B3 plus has been reduced because it's gained electrons. Next up, we've got to complete these and say what's been oxidized or reduced. So I'm going to put 2 there, and we're going to say A has been reduced. Here, I'm going to put 2 over there. And again, I'm going to say D, not 2D, just D, has been reduced. Here, I'm going to put a 2 and a 2. And I'm going to say E2 has been oxidized. In this case, I'm going to have to put a 2 over there. And I'm going to say G2 minus has been reduced. It's gained electrons. In this case, I'm going to put plus 4 E minuses over there. And I'm going to say L2 has been reduced. And again, the easiest way is to just see the charge, right? As the charge gone down, it goes from a charge of 0 to a charge of 2 minus. Oh, I have to put 2 over there as well. Okay, big mistake. You can just see that the charge has gone down from being a charge of 0 to a charge of, overall 4 minus and 2 minus on each L. In this case, what have I got here? So I'm going to have to put some electrons on this side, and there's going to be 6. No, sorry, not on that side. It's going to be on this side, my bad. 6 E minuses, and we would say 3M. Sorry, not 3. Gosh, I really am making mistakes today. M has been oxidized. And in this case, I'm going to see I've gone to a 4 plus charge, so I'm going to have 3 E minuses over there. I'm going to say Q plus has been oxidized. If you got all of those right, well done. If you didn't, go back, check your working, make corrections. If you need to go earlier in the video, please do so. The final question that I had there was this one. The student is using the equation below, and they write that sodium has been reduced because it's gained electrons. This is incorrect because they've written sodium, and it's not sodium, it's Na+. So they can either write option 1 is Na+ has been reduced, or they could write sodium ions. What they absolutely cannot do is write that sodium has been reduced, because we use that name only when we're talking about the element. So if we're talking about sodium, what we're actually talking about is this one, okay, which is obviously on the wrong side of the equation. That's all for now. I hope you enjoyed the video, and I hope you feel like you've learned something. Just by way of reminder, there are plenty more videos online to help you through your GCSE chemistry, and you can subscribe to get more. And I've tried to make as many playlists as I can to help you navigate them. Thanks so much for listening, and have a great day.